Okay. Well, the idea of this work is to present a simplified way of solving some problems that are frequently presented in industry. Here, we have several sources of information. For example, measurements from different places, and then they affect one to the other. They are overlapping one to the other, and you have a big number of different sources, and we want to separate and identify each of them. So many problems related to that has been solved, but I think that it is possible to solve that problem in general using a very simple way, using simply the physiologic compatibility index. And so, more or less, that's what I am saying here. So we have fuzzy vectors receiving, and what is the advantage of the physiologic classification? Reduced application development cost, reduced application execution cost, and reduction application maintenance cost. Here we have the basis mathematical element that define the degree of similarity of two different functions in general, known as A and B. And of course, that I am not going to go inside this very deep. Simply, we accept that it is the possibility, and then we find out the compatibility index of two different systems in this way. Where here we have presented different weights for different signals, and in general, the cases that I am solving here are the same way for all of them. So we find out the compatibility index of all the functions having the same weight. The first example is a very old example, the Irish classification obtained by Fisher, and he defined it, or they are defined, three types of flowers, or orchids, setosa, versicolor, and virginica. And the attributes he measured was this. And I used that because there is a very good table for analyzing the different variables in the system. So it was developed, in this case, models using normal probabilities, Gauss probabilities. And why Gauss probabilities? Because it is very easy to work with them, and they are applied in a very big quantity of problems. So we define, for starting from the table, for each of the different attributes of different flowers, setosa, versicolor, or virginica, we find out the attributes that we have defined like basic, and having them the medium value and the sigma values. Here we have then solved several examples. I have solved a lot of examples of this, but I take only few of them. Of course, we cannot use here, include here a lot of different examples. And in this case, these were the values given by each flower. And then we get the different values of each of the elements taken, of the rows taken, the row 41, 42, and 43 from the table. And we get from there the values for the different flowers. Then we find out the compatibility index applying the formula that we have defined before for each of them. And then we see the value of the compatibility index. For 41, it is 0.6, comparing setosa with versicolor, and 0.09, the number 2.11, the number 43. And then we compare it with virginica, which gives also a compatibility index very small. And the conclusion is that it has to be setosa, which gives a compatibility index very big in the calculation. So we can identify the setosa in this case, in the example. The same can be done with others. Here I presented the representation using the median value and the standard deviation value between setosa and versicolor, and note that the coincidence here is relatively small. It is easy to differentiate them in any model because they are a small coincidence. We will see another example where this coincidence is much bigger. In other works, of course, we have not the possibility of presenting it here. In other works, it has been calculated the precision and the error that you may commit when you make one classification or other. And of course, it depends on the area of the coincidence or the overlapping of the functions. So that's with respect to this. We used the method and solved it in a very simple way, not going through more complicated things that could be, for example, and I have been myself done that using information theory or using artificial networks. Here you solve the problem in a very easy way. That's the objective of this work, to solve this using very simple situations. And here we have another, which is the Avalon classification. In this case, let me tell you, not necessarily you need to know what is the Avalon. Those are some shells that are very expensive, and the price depends very much on the age. And the age is determined by the number of rings, among other characteristics. And then here, the classification has been made in young and old. You can put middle, etc., other characteristics for the classification, but in this case, as they are very coincident, as you can see here, young and old know that the overlapping is very big. So the error can be very big. And if you increase the number of different possibilities, as I said, in place of young and old, you can interconnect there other different values like middle, middle, old, middle, young, etc. and this, of course, will make the system has to be more, the measurement has to be more precise, and the error will be bigger. Same situation has been presented for the young, where we have constructed the model, and for the different parameters under mediation. This has been defined before, these attributes, length, diameter, etc. And they have been represented here for the model for the young and the model for the old created with them. And then it has been calculated, or it has been used. The previous obtained information from in the references can be found, all these tables and information that I, of course, cannot include here in detail. And then we have that this is a zone, but in the limit already of zone, and the compatibility index for it coincides bigger than for the old. So we have for young that we know that is young according to our definition. Then we have that the model gives us that it is effectively young. So we have another which is young, and again we have made the calculations, and the conclusion is given by the model exactly. Also, this can be done, and I did only, it can, in the literature, in the references, there are different ways of doing that. And here we have selected only a few values or a few measurements. For example, if you have a big industry, let's say a plant, an electrical plant, and you have a lot of measurements, then if you reduce that lot of measurements, you can have a bigger savings because you are measuring less values, and you can get faster solutions. And here I have selected, for the same situations, I have selected, this is the number of rings, which is equivalent to the age, and here we are defining the age of young and old, and we obtain here the model, the different models, and the compatibility index for each of them. Know that here we say the one that was example one that was in reality old, it gives 16.5, which is a number, a compatibility index obtained from the compatibility index, and it is old, and the others similar. Then we apply it, this to different, only I presented here only a few of them, but we apply it to different situations, and the system always worked, the model created with the compatibility index in place of using other type of solutions gave good conclusion, gave good results without a big complication in every mathematical, or when we deal with systems, you have to have a lot of sensors, a lot of elements in order to give the proper information, in order to take the proper decisions. And that's what I want to present here. Simply we have simplified a problem and solved it in a simple way, which has been solved by others doing complex calculations, complex approaches. So here are the conclusions. When we are dealing with databases, of course, if the historical data is available, as we have with the abalone and with the flowers, the attributes minimization and classification using fuzzy logic is extremely useful. If the number of possible values of the attributes is large, the selection of interval values is mandatory. So we cannot, for example, in the abalone case, we cannot select year by year. We have to make bigger interval In this case, I selected only young and old in order to solve it in a simple way. If you select more different values, obtained values, then you need to increase the precision of the medition, of the measurements, you need to increase it. And if looking carefully to the factors that affect sumlet selection, it is possible to minimize the number of attributes under certain acceptable precision in the response. That's what I say, that it has not been demonstrated here, but in other works, even my works have been demonstrated how numerically, how you can get the errors and what is the necessary precision for obtaining some result. An extension of the method permits to know, well, what I said, permit to know the relationship between acceptable error and the number of output regions. Well, that's it. Thank you very much. See, if you have some question, if not, thank you. That's all. Yes.